In 1687, Isaac Newton published one of the greatest scientific works of all time. In short, it was called Principia. Newton stated 3 laws of motion that form the basis of classical mechanics. In this video, we're going to be looking at Newton's first law of motion, which is also known as Galileo's law or the law of inertia. In his first law, he states that an object at rest will remain at rest. An object in motion, or actually in constant velocity, will remain in constant velocity unless an unbalanced, or we usually call net force, acts upon it. Okay, well, an object at rest remains at rest. Well, that makes sense. Unless an unbalanced force acts on it. I mean, you have a book on a table, for example, and that book will just stay on that table and not move because the forces, like the normal force and the force of gravity, are balancing each other out. And it's going to continue to stay at rest unless there's some unbalanced force, like a hand pushing it to the right, and causes the book to move. The harder one for you to conceptualize is an object at constant velocity. And constant velocity is going to continue moving in a straight line with no loss of speed, with no force acting on it. Now that notion is very difficult for people to understand because many, many years ago, a philosopher named Aristotle stated that, he basically classified motion into 2 types, natural motion and violent motion, and said that objects at rest were at their natural state, and then objects that were moving or caused to move, they were in violent motion because there was some force that was acting on it. And so to make it move, he said that you had to continuously apply some force on it. Well, that's not true. I mean, if you think of a hockey puck sliding on a very, very icy surface, it's so icy that it's frictionless. Well, that hockey puck would just continue moving in a straight line at constant speed and never change without any force acting on it. Now, that notion of a force needed to keep an object moving was demolished by Galileo. Remember Galileo Galilei, who dropped objects off the Leaning Tower of Pisa? Well, he stated that you don't need a force to keep an object moving. So if you get rid of, friction and air resistance, the object will continue in a straight line motion. One of the key ideas in Newton's first law, and the reason why it's called the law of inertia, is this idea of inertia and force. Those are the 2 key ideas. Now, inertia, you should understand what that term means. It's a property of all objects that have mass. And it's the tendency of that object to stay in the same state of motion. Whether it's at rest, it wants to stay at rest. Or whether it's moving at a constant velocity, it's going to continue moving at a constant velocity. The more mass you have, the more inertia, the more sluggish you are, and harder you are to change your state of motion. So there's all sorts of examples that one could think about that kind of demonstrate the law of inertia. Can you think of a few? Imagine you're in a car and you slam on the brakes. Your body would be thrown forwards like this little crash test dummy. There's no real force acting on you and pushing you forward. It just means that you have that tendency of your body to continue moving in a straight line motion. That's the inertial feeling that you're feeling. You feel as if there's a force pushing you forwards. That's just because your body wants to continue moving in a straight line at the same speed it was going, but now it's suddenly the vehicle you're in is slowing down very, very quickly. And so the airbag here and your seat belts are acting in the backwards force. That's the real force that's acting on you. Or here's an easy demonstration you could do at home. Place a quarter on top of an index card or a credit card or whatever that's on top of a cup, and then flick the card or the credit card off, and you'll suddenly see this coin will stay still because it has a tendency to stay at rest. Or here's another demonstration. Maybe I wouldn't recommend you doing this one at home, but magicians sometimes yank very quickly a tablecloth with a fully set amount of dishes. relying on the property of inertia. The dishes will have the tendency to stay at rest due to inertia. When objects are remaining in that same state of motion, whether at rest, which we call static equilibrium, or remaining in constant velocity, which we call dynamic equilibrium, we say that the object is in equilibrium. And when equilibrium occurs, the vector sum of all the forces is equal to 0. And so this is how we write Newton's first law mathematically. The sum of all the forces equals 0, or the net force is equal to 0. This is known as the equilibrium rule. And one last thing about inertia. You might be wondering, well, how do we measure an object's inertia? Inertia is kind of like that sluggishness of an object. How do we measure, quantify that quantity, that property of an object? Well, the physical quantity that measures the amount of inertia of an object is mass, which is measured in kilograms, and we'll study that later.